So in the last class, I have explained about that stack implementation in C++. Today discussion is about the queue implementation. Just like how we implemented the stack, in the same way, today we will implement that queue data structure. First of all, so what is that queue data structure? How can we create that queue and how we perform the operations? So we need to understand. First thing, queue means what? Just try to imagine the queue line. Try to imagine the queue line, like at box office, right? In all the places, how the queue lines will be in the same way. Just here it is. I'm taking the queue with the particular size. And here it is again, I'm telling how we implemented that stack with the fixed size. Queue also, we are implementing with the fixed size. Initially, I'm taking that size. Now here, all the insertions into queue from rare. From rare, all the insertions happen. All the insertions from the rare. Here it is. If you want to insert, we use what? Rare. If you want to delete, all the deletions from the front. But a very important point here we need to understand. One point, that front is always fixed. Is a delete that is from the front. But a very important point, and of course this is index 0, 1, 2, 3, 4, 4. But the point is what? Is a front is always fixed. Front location is always fixed. No one can change. Just imagine in the queue line, how we move. Suppose if you want to enter into the queue from the rear, we will enter into the queue. We will move like this. We will move. Suppose at box office queue. Here the ticket counter is there. We are getting the ticket and we will come out of that queue in the same way. In the same way, front location is for deletion. And the point is what? Front is always fixed. You cannot change. Then all the operations we are performing with the help of rare. With the help of rare. Rare value is initially -1. Front value is always 0. That is fixed. Okay. Now the same. Here it is we are taking. First one is a cube. Size initially 5 I am taking. Of course, I am giving that size is a 5. We perform the operations using front and rear. Front is a fixed value. Just make it fixed. Rear value is not pointing to anything as of now. Rear is a -1, just like a top value -1 in the stack. Here it is. So while is a 1. So then all operations as usual. First one is for inserting. Second one is to delete. Next one, third one is for traversing. Traverse means what? Is a display. Fourth one is for peak. Peak means what? What is the front element? What is the next element is going to delete? And that last one is a exit. These are the 5. And then we ask, so what is your choice? What is your choice? We just collect that into that variable ch. We are collecting that choice variable. And then we ask if the choice is equals to 1. All the things we are writing just like the yesterday code. else if choice is equals to 2. Choice equals to 2. Else if choice is equals to 3. Else if choice is equals to 4. Else if choice is equals to 5. All the 5 options we are giving. If they enter other than 1, 2, 3, 4, 5, so you know that just to see out is invalid choice. Invalid choice is a 1. Got the point. Now in this one, the first one, if choice is equals to 1, we ask them to insert. Insertion is the same almost like a stack, only the deletion is completely different in queue. So what is the difference? That is only the main discussion today. Here it is. If the choice is equals to 1, first we need to check if queue is full or not. If it satisfies some condition, then we can say that queue is full. Nothing but queue is overflow. They call full means what? Is overflow. Is a overflow. If queue is not full, we are inserting through rare. So first we ask them to enter the element to insert. Enter element to insert that we collect into variable element. So we are declaring that variable element and then increasing the rare value. Increasing the rare value, simply rare plus plus. And here it is simply queue of rare equal to that element. Just simply element inserted. Element inserted into the queue. This is else. And then what is if? If block means what? When we keep on inserting. For example, that rare value becomes 0 and that element 10 inserted successfully. Next, rare value 1 inserted successfully. Rare value 2 is inserted successfully. Rare value 3 into the third location element inserted. If rare value 4 is element inserted. What is the size? Size we know already, size is a 5. It's the same like if rare value reaches 4 is nothing but size minus 1, then we can say that queue is full. If the rare value equals to the given size minus 1, then we can say that queue is overflow. It's nothing but full. We cannot insert the data. We cannot insert the data. That is. Okay. Now, here it is. If you want to delete, is a letter followed by will, right? Followed by. Third one is a traverse. Traverse means what? Is a display. But while displaying, we need to check as usual. If queue is empty, you can't delete. So when the queue is empty, as soon as queue is ready, queue is created. By the time rare value equals to -1. So we can say that when rare value equals to -1, we can say that queue is underflow. Queue is underflow means what? It's empty. Is empty. If queue is not empty, then we can display the elements. The queue elements are the queue is, we are repeating the loop from where to where. Either you can use a 0 or you can use a front also, because front is always 0. That is fixed. And up to rare. Rare means what? Here, suppose the 5 elements are there. So rare is pointing to this 4. If, for example, only 4 elements are there, rare is pointing to 3. So don't display up to that end last location, just up to rare. So index starts with the front location up to rare less than or equal to rare and I++. We are just printing We are just printing that q of I with a line gap giving every time. Line gap. If q is empty, directly we can say that the q is underflow. You can't display the elements of q. If q is not empty, if q is not empty, then we are printing that q. What is that? Here it is. We are printing all the elements. Next one is the fourth one is what? Peak. Peak means what? Is that starting element. What is that next element is going to delete that we need to print. So that is what peak element. So here same story. For peak element also we need to check that q is underflow or not. If q is underflow, there is no peak element. Right? If q already having elements, just front element we need to display. That is peak element is just q of front. Q of front. Then end line. Then end line we are giving. This is what peak element. And the fifth one is what? It's easy. That is end of Q operations. End of Q. End of Q. And we just break the loop. Terminating by breaking that loop. Only concept here we need to understand in Q. That is the limitation of Q. That's the only reason. Double-ended Q and circular Q introduced. So what is the reason? This is the only reason. What is that? Just imagine if you are in the queue line. If you are in the queue line, just imagine. And you reached that first location, nothing but front location. You have collected that ticket from the ticket counter. You collected the record. Then what you will do? You will walk away from the queue. Yes or no? Whenever you are deleting, from the queue, nothing but you just walk away from the queue. Then what will happen? If you see some of the programs in internet, how they give you, simply they will use a front plus plus. We should not do front plus plus. The counter will not move. The counter will not move. The people behind you will make a move towards the front, just one step front. That is actually Q. That is actually Q. Simply, the 20 has to come. The 20 has to come here. 30 will come to here. 40 will come to here. 50, that rare will come to here. That rare will come to here. That is the procedure. 20 will come to here. 30 will come to here. 40 will come to here. 50 will come to here. How can we make a move? From first location to rare location. From which location? From first location. First we have to check. Q is empty or not. Because the same story. If rare equals to -1, if Q is empty, how can you perform the deletion operation? You can't perform. You can't perform the deletion operation. Got it? Right. If there is a chance, first of all, you are saying that deleted. Deleted. Which item is deleted? Q of front. Q of front item is deleted. After that, we are repeating the loop. For I starting from first location to rare location. Rare, every time, look at this. You are at first location, I equals to 1. That first location element, you need to move to 0th location element. Nothing but, suppose I value 1. Ith location element, you should move into I -1 location. queue of ith location element, you need to put it in queue of I minus 1 location. This is shifting the elements. This is very, very important. So all elements will shift up to rare. Fourth element will go to third. But finally, rare is not 4. Na? This is also a very, very important step. Everyone will miss. After moving all elements, that rare also you make a move. Rare value become 3. Now rare is not pointing. I already told you that. You just make the pointer pointing to this one means what? That is not the concept of deleting the item. Physically, we are saying that item is deleted, but rare is now pointing to, rare is now just pointing to this location. Now imagine just the insert, then rare value you increase and that you will replace with the new value. By that time, that existing value will be replaced. So finally, that final step is very, very important. This one is a final step, rare minus minus. This is actual deletion. This is only the limitation of queue. Problem with the queue is what? Problem with the queue is what? Whenever you are shifting the items, shifting items taking so much of time. Shifting items taking so much of time. That is the reason they introduced. That is the reason they introduced in shifting the items, double-ended queue and circular queue. In circular queue, front also will move instead of shifting the elements. So when you run the code, just checking that outputs, okay, all are belongs to. Here it is. I int we need to specify the data type. Now we are writing that we keep on inserting 1, 10 inserted, 1, 20 inserted, 1, 30 inserted. Now if you display 3, traverse, 10, 20, 30, I just want to delete a peak item, for example, 4. Peak element is a 10. The 10 I am going to delete. That is second one. The deleted item is a 10. So we keep on deleting 2, 20 deleted, 2, 30 deleted, 2. Queue is underflow, is nothing is there to delete. Just 5 is exit. It's end of the queue. It is end of the queue. This is the simple way of inserting that queue data structure. I already told you in the last class how we implemented that stack. In the same way, we implemented that queue data structure also. Okay, so hope you understood.